Hello, everybody. I'm Alex Reggiani. I'm a geologist. I come from Italy, and I work even in Italy. So I founded GeoMITS, that is a company that has the main focus to supply not only geopolymer binder, but also automatic mixing machine to solve the big problem of mass production. And in this presentation, I present the automatic mixing system for geopolymers and for mortar and concrete production, and of course for 3D printing. So in this presentation, some general information about what we do with GeoMITS, the portfolio about mixing plant, but is possible to customize the dimension of the machines because we are enlarging the production, and the geopolymer production that I tested with this machine, just to say some example, and the final properties that I obtained. And okay, GeoMITS, Material Innovation Technology Services, are our focus. So we do consulting, R&D, and supplying about geopolymer binders, so even reactive powders, then liquid hardeners for several applications. We customize the automatic mixing plant that could be mobile or fixed like a central beton for production from laboratory sites to industrial scale. So we supply a 360 degrees services about designing on the final geopolymer recipes, included the choice of the best partially reactive aggregate curve. This is, for me, most important than the geopolymer binder. And for this reason, at the end, we make an intermediation between our clients and the aggregate supplier to reduce at best the final cost, so to permit the diffusion of this technology. So this is our portfolio. This is the little one, but it's possible to start with 5 liters, because last year I presented 5 liters half automatic mixing plant. This is half automatic because of dimension. It's possible to, you need to charge your raw material and to clean by hand. But all the automatic process, so dosing and the speed of mixer and how fast it will mix, is completely automatic. And you can see the consumption and the electric power, installed electric power and the electric power consumption are quite low, so it's, every laboratory can use it. And this is the most interesting and the already realized plant that was studied firstly for 3D printing application, because 3D printing has a process that is not so fast, but is possible to regulate in cycles. So using geopolymer, you can't work in a continuous mixer like a Portland concrete. So you need to organize every work in batch, precise, and you have to start following a process. We patented this process, and this machine. And this is the feature. So there are 2 mixers of 85 liters, for this is the name, 2.85, and the production could be from 400 to 2,000 kilograms per hour, considering 2 mixers, depending on the density of the final material you have to produce, of course, because it's possible to produce also lightweight mortars. And the installed electric powder is 12 kilowatt, so it's quite low for this kind of plant. And the dimension permitted to charge on a truck or in a container. For this reason, is mobile. And he has, on the left, you can see 2 diesel generators that are included, so you can work without any connection to electrical power. So in the desert, in what we want. And this is completely automatic and is self-cleaning and self-drying. So at the end of the day, you have the machine is clean, and you can switch off the key and return the day after and restart in the perfect condition. No waste of time. And this is the big plant. the biggest that we have at now, is the mixer is one only, and it's quite big. The capacity is 1.5 cubic meter, so it can produce every batch 1 cubic meter of geopolymer concrete or mortar or what you want. And of course, the production is higher, so it's possible to arrive till 8 to 10 tons per hour, depending on the density, of course. And the installed electric power is 52.6 kilowatt, and the electric power consumption is 27 kilowatt. This is, of course, is fixed. So the alimentation of the product is made by silos and by tank. So is only for industrial production. And this is just a video of what will be using a truck. So this one, and finally, this is what I have now in my warehouse. So on the bottom, you can see that is very simple now, but we have two options, depending on the density and the consistency of the material that you have mixing. If you have a material quite fluid, you need a filter press that can separate the waste more heavy, that can be pressed and let dry and reused as an aggregate. And the water, we reuse the same water, because geopolymer technology can permit to use not only tap water, but also seawater, dirty water, polluted water, just a liquid to change the consistency of the mortar or the concrete. So this is a little video just to show that I'm already using this machine. So this is the control panel, is a normal touchscreen panel, and everything is automatic. So this is the loading of reactive powder. I remove the rubber to permit you to see that something is fallen in the mixer, because this is not a problem, but here you see the dosing of the hardener, and of course without the rubber something can exit. And this is the dosing of the aggregates, and even with a membrane you have no dust. And this is the main process from the control panel. You have under control every parameter, every step of the mixing that is automatic, and you can modify till 500, you can charge till 500 different recipes. And you need only to charge the correct premix raw material from one side and another side. And this one is what the mixing is finished. It rounded and it discharged the material. And then you can use some resting time or pump the material to a 3D printing machine or a line of production of elements, precast elements, or what you want. And these are 4 examples that I tested with this machine. And the minimum amount of material that is possible to realize with very precise dosing, because everything is measured with balance, is 50 kilograms. So 50 kilograms is the little possible amount of mixing for this kind of machine. So we start with the 3D standard mortar. That is the same mortar that with Andrei and Marina we printed a lot of time. And so I tested several mixes, changing sometime the workability to prolong a little bit the setting time. So this was a test of 2 weeks ago, so very recent. And I prepare a lot of different samples, because with 50 kilograms I have a lot of material. And after a few days, you can see that the product become water repellent without any additives, just because of the chemistry and the reaction of geopolymer. And this part on the left, on the right, you can see test under seawater, because I tested in the Laguna of Venice, just to be sure that that can resist to polluted water, because Laguna Venice is terrible seawater. And this is an example of, I named tegola. In Italian, tegola is roof tile, and is my recipe for roof tiling that passed. You will see in the result, it was the best product that I realized for this application. And this, I realized also a big tile of 4 centimeters of thickness and 60 for 60. And of course, here I had a little additives to obtain immediately after hardening water repellency, because it's mandatory for this kind of application. And what you can see here is the roof tile that I tested. You can see the 722. This was the frost-defrost cycle when I removed the first time, and then but wasn't broken. So I re-put in the machine, and the machine stopped after 1,000 frost-defrost cycles, but the tile is still not broken. So I removed and I kept in the lab. And this is humidirt. You see before by Andre. I add, because my client requested water repellency, so I had made this kind of recipe with a little bit of water repellent agent, and you can see the result on the right. And on the left, you can see that it's possible to use also ferrosialate geopolymer binder to realize the humidirt, in the red one on the left. And these are big prism for flexible strength, and other shapes that I realized with 50 or 100 kilograms that I tested. And this is castable, so more fluid for create some particular object, furniture, sink, like this. And this is a light gray geopolymer binder. And I have other, so this is white. And on the left, during preparation, fresh state, and on the right, 24 hours later. And I have also other binder, of course. So these are more beige because I needed to replace some sienite that is like a granitic rock with low grains, so like a rock. And this is light gray seen from the above. And of course, the water repellency test, because it's a sink, so water can be absorbed. And I test by air, and I verify if it's a geopolymer in water, of course. And sometimes I test even in boiling water, but it's not a normal test because usually I have no time to do everything. And these are the results that I obtained from the recipe that I showed before. So for 3D GP, the density can change from 2 to 2.2 depending on the type and the quality of aggregates, because I use the same binder with the different aggregates. The lower result are obtained with standard sand, silica sand, because every time we made the testing, every client has quartz or silica sand because it's cheap, because it's at disposal worldwide. But I prefer to use feldspar rock, so the data, the most high data are obtained with feldspar rock that are also quite cheap or cheaper than quartz. And so you can see that after 24 hours, you have from 3 to 5 about flexural, and from 12 to 20 about compressive. And to arrive at 28 days, so with a compressive strength between 33 to 50. And this is normal result. It's possible to do better. I obtained also 90, changing the aggregate. I have brought with me some little pieces using zircon waste. And with zircon waste, you can arrive at 90 without any problem. And defrost cycle, resistant, and acid base. So I made the test in comparison with Portland cement standards, just because I work on sample prism 4x4 for 16, just to be comparable. And the Tegola GP roof tile is is lightweight, because this is a project that a manufacturer in Italy of roof tiles, cooked roof tiles, clay minerals, He wanted to reduce the density, to transport, to reduce the cost of transportation of the tile to their clients. And so I reduced the weight of 33%, and, but I passed all the parameters, and I passed more than 1,000 cycles, and they compared to years are 250 years. This is I haven't done this test. The test was done for this roof tile manufacturer, and the final strength could go from 24.5 to 30 megapascal, depending on the fluidity, because this is a fluid material, but some manufacturer can manage only butter-like consistency, so with no water, and so they press with the rubber press elements. And so humidirt, I found I compare my hand press product with the industrial press, because I have a client that already used this solution. So my 27 to 40 about the different quality of aggregate that I used become 73 to 80. And this is good for self-blocking industry to be resistant to the abrasion. And the cast table has an average of other consistency, so are more fluid, not like roof tiles, and quite isotropic, not like a 3D mortar. And I obtained a result very interesting. And depending on the size and the granulometry, it's possible to rise up to more than 10 MPa about flexural strength, and about 75 or 80, depends, about compressive strength, with good stability in acid or basic medium. So, thank you for your attention. And these are our general contact if you wanted to, if you are interested to go deep.